All right, in this recording, I'm going to show you guys really quickly how to use Decimation Master. Um, this is typically used for 3D printing, and it's trying to find a perfect algorithm to take this 5.6 million polygons down to maybe 300 or 400,000 verts. So it's basically doing an algorithm and trying to figure out where to delete polygons sorry, and where to keep them to keep that same unique spirit of this, but also to decimate it. So some of this I may go in here and delete, or I may keep it all in here. You may have to fast forward it in, on YouTube. But let's go ahead and get started. So we're going to go into our Z plugins and ZBrush. And we're going to look for Decimation Master. Again, we're at the highest level on the geometry over here. I'm on a 7, which is way too high for anything manageable. But I'm going to keep on 7, and then I'm going to go to ZBrush, Decimation Master. Mine just went blank there for a second. Okay, and we are going to pre-process current, and then we'll decimate current afterwards. But you got to pre-process it first, and I think it should be 20%. Let's go ahead and go with that. That's going to knock 80% of that 5 million out of the way. So I'm going to go ahead and pre-process, and this is where I'm talking about where this may take a while. So this may take up to 4 or 5 minutes. Again, your computer will just really start screaming really loud, and will take a while. So I'm just going to go ahead and let it go. It's going pretty quick here. Again, you can kind of scoot forward on here. You can kind of get the idea that the computer is doing all your work, and you can go get a drink, or get a snack. All right, so hopefully this will knock it down, and we'll probably knock it down again another 80%, go down maybe to 10%, and see what it looks like, and then we'll export it and get it ready and prepped for 3D printing, let's say in a resin. This is probably not good for 3D printing for with filament or an additive process, but it would probably be better for a resin print. And we'll talk about maybe some other opportunities that could be cool for resin also. All right, again, you can fast forward it. This is taking a while, and so we're done. And it hasn't done anything yet. We're still at 5.6 million, so we're gonna go back into our plugin, and we're gonna go ahead and decimate current. Okay, so it's going to take that pre-process, and then really quickly it'll decimate it and knock it down. All right, so we went from 5.4 million down to 1.12 million. All right, and you can see as we go around here, and also if I hit this is the draw poly, you can see where it's starting to get a little bit softer and where it's putting a little bit more of the geometry. So I'm going to click that back off. So we're going to do that one more time, keep decimating it down, and hopefully get it to a point where it's so-so. So instead of 20, let's go ahead and knock it down to 10. Right? And you can go in there and numerically type it in too. You don't have to do the slider. So I'm going to go ahead and pre-process the current. All right, so we're taking that 1.1 million, which is a huge amount of data, and no 3D printer would be able to take that much information and deal with it. So I'm calling it 200, 300, 400,000 vert. Again, I need to reach out and see, or even Google it, what is a good approachable vert for that. So these are active points. So I'm going to go back in here and decimate current. All right, so we're down to 112 polygons. That's pretty amazing. And look at the resolution. So I'm going to go ahead and click on here, and we can see a lot more color coming through. You can start to see where those polygons are putting most of their weight mostly around the edges, right? And then these topographical meshes and so forth. So I'm pretty good with that. 112, that I can't believe we even got to that point. So if we were doing additive, we try to stay around 20,000 verts. So with resin, I'm hoping and guessing that we can go up to 112. Again, we'll reach out to one of our classmates and see what is a good threshold. So I'm going to stop it there with decimating it down. So, but that's pretty good. Again, we could not bring this into Maya and rig it. It's just way too heavy. That's why we did the box modeling, so we could rig it. But again, you could bring this into Maya just as a standalone prop at 100,000. It's a little heavy, but doable. So we're gonna go ahead and we're gonna go in here, and I think we're going to take it where we can export this out, and I think it's called 3D Print Hub, and we are gonna export to STL. All right, and we could also export as an OBJ. I think before we do that, we update. We're gonna go back here, Z plugin, and we're gonna update the size and ratios. We haven't really done anything, but basically this is 0.9, 0.7, 0.32 inches. That's tiny. Let's go up to here, 8 inches. That's huge, but I'd rather it be a little bit bigger than micro scale. So I've just updated the size, and we're gonna go ahead and export. I'm gonna go to OBJ, even though if we were going directly to a printer, we'd go to STL, but let's go OBJ. And we're gonna go back to my Grasshopper. I'm gonna make a folder called Printing. All right, I'm gonna hit create. And go ahead and put in a word called print, not pint, print. And we'll go ahead and hit OK or save. I'm gonna go, for good luck, I'm just gonna go ahead and do a ZTL also. Print, STL, save. All right, so we've taken something what was 5.4 million down to 1.1 million, and then down to 112,000 polygons. So we've done some substantial knockdown, and I think it looks pretty good. I think it looks exactly the same, and a tenth of the weight, or even smaller than that, 2% of the weight. So now we're going to go into another software, and this is called Mesh Mixer. All right, so we're going to start with Mesh Mixer. I'm going to open up the file, and we've got the Grasshopper OBJ, and we could have selected STL. I'm just going to go ahead and use the OBJ. All right, so I'm just going to go through a couple of things, and again, this may not be perfect. We will kind of get this started in class and then see what is the appropriate thing. So one of the things that we want to do is kind of import it in, and then we want to work on our units. Right now it's quite tiny. If you look at the bed, that's kind of a maker bot. This is probably 15 inches by 12 inches or something. So this is like super tiny. And this is for filament or additive process, not resin. So we want to kind of go to our edit and or analysis, and we want to go to our units. And you can see it's in millimeters. So 4 millimeters, 8 millimeters is tiny. So we're going to go ahead and bump it up to inches. And we'll keep XYZ the same. And now it's huge, right? It's 8 inches tall. We don't want that. So we want probably the longest is 3 inches, just because we're working with a resin printer. We don't want to eat up all the material. So we hit 3 and then hit enter. And so you can see everything kind of scales automatically. So we got 1.5 inches, not millimeters, and 3 inches. So 3 inches is about the size of your keys. Let's say the keys to your house or something like that. All right, so we've got 3 inches, and so we're going to hit done. We're okay with that. And we also want to do inspector. So if we do inspector, and if you brought this in from Maya, it would be a disaster. There would be some reason Maya and making watertight, even if you brought in a cube, sometimes it just doesn't come in watertight. And so it would show like these little red hashes and so forth. But since we did this in ZBrush and we also did Decimation Master, 9 times out of 10, over 98% of the time, it's watertight. But just go ahead and do auto repair all just for good luck. And that's just making it watertight. You don't want anything that is going to confuse the printer or make it stop or jam up the head or whatever. So just make sure you do a watertight on that. So next what we're going to do is work on our transform. So we're going to go into edit and look for the word transform, and basically we're going to kind of get it pivoted in the right direction. So I'm going to go ahead and pivot this, and I'm going to get 90 for that, hit enter. And then also going to kind of pivot it kind of long wise, and that's 93. We're going to turn to 90, enter, and we hit accept. All right, and one of the things I would like to kind of push this down, and I think it's under orientation. I could be wrong on this. Again, I'm kind of flying loosely on this, so we're going to hit orientations, and I think what it'll do is kind of find the right appropriate place to kind of do the printing for this. So it's going to maybe turn it upside down and slam it onto the bed. All right, so let's keep our fingers crossed, and it does turn it upside down. It's got a little bit of a warp to it. It's sitting on the bed a little bit differently, but again, these are 3 points that it's touching, and so it's ready to print. So let's go ahead and accept it, and again, we may get some feedback on the resin printer people to how to properly set this up. All right, so what we've done is imported it, made it watertight. We also worked on our proportions that we know we want it 3 inches exactly. And what you set up here is exactly what it should be coming out on the other end of the 3D printer. It should be exactly 3 inches from, antenna to the tip of the wings here. All right, so now we're ready to export. So we go ahead and hit the export here, and I've got already a 3D printing thing started. So I'm going to call it grass underscore print, and I'm going to call it 1 because I've already have grass underscore print underscore 1 already. And there, you basically want this as a STL format. Now, I do not know why there are 2 STL formats. There's a ASCII and also a binary. So we're going to do both for good luck. And again, consult our 3D printer folks and see which format they want. So it's always nice to arrive with a thumb drive where it's already there, or upload it to the library. The library already has this formatted, so it should be quite light. So we hit save. All right, and we're going to rinse and repeat. It should be pretty quick. I don't know why it's taking a while. So we're going to export again, and instead of ASCII, we're going to do a binary, and we'll call it grass again, underscore print, and underscore 22. All right, so we're going to go 3D printing. Again, this is what you would upload to the library, or walk to the library, or walk to wherever you're going to go, and have that on your thumb drive, okay? Both binary and ASCII format. Hit save. All right, so one of the other things I was going to show you is possibly, if you were going to do additive printing, we can possibly do this. I know it's a lot of weird legs hanging out, but there is a way that we could do it. So I'm going to go back to my transform, and again, this isn't my tool that I deal with every day, so please forgive me trying to find where the transform tool is. I always have a hard time finding it. There we go. And I'm going to go ahead and kind of get this in that direction. All right, we'll go ahead and accept it. All right, and there is a slicing tool. Again, give me a second. We're going to go to slicing. Not slicing. Actually, we're looking for plain cut. Sorry, plain cut. So let's do that. Rinse and repeat. Plain cut. So if you can see it, yell at me over the internet. Plain cut. All right, there we go. And so what plain cut does is that you can cut something in half and then print the other half, all right? And so what we want to do is a plain cut, but in this direction, not this direction. All right, so we're gonna go ahead and hit cancel. And we're gonna go to a transform tool. And I'm gonna bring it in half like this. And try to do my best. We wanna go to get this at least somewhat in the middle here. All right, again, I would probably bring it in. Again, it's more in the 90-degree angle. Go ahead and accept, and then we're gonna do a plain cut. All right, and so we're gonna go ahead and try to see where that is in the middle. Again, you're gonna print out 2 of these, and they will be able to glue together. All right, so what we want is cut and not disregard the half, but keep both. All right, I'm gonna hit that and hit accept. All right, and so now we should have 2 parts in here. And I forget how you select those 2. It should be showing up here on the side. So generate face grips, and so you can see it right here. And so basically you would save out the top part and then the bottom part. And again, when you go to print, this base part would be sitting on the table and printing out and going upward. And then you would take this part, flip it so it's facing down. And again, it's printing this base material and going upward. And as it's going up, it's building up this material as it's going up. It may do some supportive material for some of the feet. It may bring a little bit of the base here and here. And as it's going up, it's building up that material. So this is a way that we could do this additive, and I didn't think about that till halfway through. I was like, oh, I forgot you could probably split this in half, and you could probably split this in half again, and add these little tiny parts that would be like maybe 1 inch big and super glue them together. All right, so I wanted to show you that. I didn't do a good job of separating these. I'm gonna hit Apple Z to undo what I did. I'm gonna hit separate shells. I think that was the part that I wanted to do. So we can export this as a STL and then export that as a STL. Okay, so this is, you would delete these probably. Let's trash those and trash that. All right, and so you can export that as STL and export that out. Those are 2 separate objects, and you can see how nice and clean those are. All right, so I went a little too long on that, but I do want you guys to understand that you can take whatever object you have and split into multiple spots. And I'll actually show that with my own work. You kind of saw a little bit of the beginnings of it with my multi-arm form that has tons and tons and tons of splits in it, and 56 parts to make one giant object. All right, I'm gonna stop here. Good luck, and I hope you guys do take advantage of the library and do some 3D printing. I'd really love to see you guys wearing this as an awesome necklace or a hairpin. All right, good job, guys.